Okay, so we got a little bit more of anatomy stuff to do, and then we'll basically be looking at on-the-job stuff for phlebotomists. Okay, so bear with me a little bit longer in all this anatomy. But you're sort of right at the most important part of your anatomy, in my opinion, other than blood composition, which we covered at the beginning of class, and we will cover again thoroughly just to make sure you got it. Who's ever seen Black Hawk Down? Yeah? Shay, you're a little younger. I'm not downing you or anything, but there's a guy in it called Josh Hartnett. He used to be like a heartthrob, right? Back in the 90s. Backstreet was big. I'm going to show you a scene of that video real quick to demonstrate.
How old do you think I am?
26.
I'm 23.
Okay, I was close. I figured you had seen it, but as soon as I know you didn't know who Josh Hartnett was, I knew you were young.
If I see a picture, I'm like, but I'm not good with names. I just remember.
I can pull a picture up of this dude.
Yeah. See, I've seen them in movies and stuff.
Yeah.
But I just don't know I'm bad with names.
Now there is a little bit of language in here. It's just like a 3-minute video. Catch what he said about the femoral artery?
Your heart rate too far, I'm sorry. No more IVs, so it's the femoral artery, but I can't see it, which means that it's retracted up into the pelvis. It's retracted, which means that I have to find it and clamp it. The only way to stop the bleeding, I've got no more IVs, so I'm gonna need you to assist. Okay? Yeah. Now listen, Jamie. I gotta do something, it's gonna hurt. Okay? I gotta cause you more pain, but I have to do it to help you. Alright? You understand? I can't. It'll lower your heart rate too far, I'm sorry. Your Twombly, why don't you take his hands there? I need you to hold
don't got no legs. So, are y'all okay? Kind of gruesome. It's a true story. It's about a squadron during Operation Desert, not Operation Desert Storm, but when we were invading Afghanistan or somewhere, they got stranded and like it was a huge firefight. They got really big ambushed. So it's a pretty good movie. So the guy was wounded and he was bleeding big time. We think about bleeding in here when we puncture just the size of a needle, you know? It's not lacerations or tears. It's just tiny punctures we're making with needles. But we're puncturing vessels for sure. That's what we're guided to. So I want to make sure we understand the process of clotting, one, because you might be studying it. If you recall your diagram on the next, let's see, we should be all looking at page 110 and 111 right now. Oh, yeah, 110 and 111 right now. But if you turn the page and look at 12, you see that diagram we've looked at a bunch of times. Okay, so we're talking about more of the physical aspect of what's happening rather than the chemical aspect of it, all right? It's like saying, I've told you about what kind of fuel makes a car run and how it combusts and the additives inside of it and all that, but now I'm telling you how the engine turns the wheels and where the car goes type stuff. That's probably a poor analogy. But when we need to clot, it's called hemostasis. Don't get this word mixed up with homeostasis or all the other H words I keep relaying to you and warning you about in here, okay? Hemostasis meaning what? What's this first part mean, Cheyenne?
What's blood?
Blood, and then
Is that clotting?
close, but no. Something's in stasis. Haven't you ever watched a sci-fi movie where they're like in cryostasis? Like, you ever seen Aliens?
Like stagnant almost?
Stopped. Yeah, you're good. It's stopped. We need to stop the bleeding or keep it stationary. And there's two, there's a primary, basically two major steps that happen that we're going to break down, and a secondary. And these can be broken up in the two steps each. So the first one is called the vascular phase. Let me make sure I've got that right. Yeah. Number two, it's called the platelet phase. Platelet. Number three, read it there to me. It's in purple. Page 1.
Okay, the coagulation phase?
Coagulation phase. Number 4 is the fibrinolysis. Is that IN or IN? Fibrinolysis. Looks good. Yeah. So we've talked about coagulation studies and pro-time and all that, but look where it's at in context of this word and all these phases. There's lots of things got to happen before we actually start to coagulate. This is a really neat process. So that video really has not much to do with it, but it does highlight this first phase really well. I'm going to read to you from 111, top left. Rupture of a vein or artery causes an immediate vascular spasm or contraction of smooth muscle lining the vessel. We know what that is, tunica media, right? This reduces the vessel diameter, substantially reducing blood loss that would otherwise occur. This contraction lasts about 30 minutes. For capillaries, it may be enough just to stop the bleeding altogether, such as when you get a paper cut or we poke our finger for blood. They'll seal off eventually. Okay. So you should know that this is the vascular wall being injured. Wall is injured, and the vessel spasms and contracts. Did y'all hear anything about an arteriospasm during the radial blood draw lecture? It can be painful.
Oh, yeah.
A lot more, it may not, I don't even know if it's really in major veins, but in arteries for sure. And that's what was happening to the old dude on the TV there. It just retracted up into his pelvis or whatever. I don't know how accurate all that is to medicine. Now, you don't need to know this, but what's cool, how this actually works, is that the cells in the endothelial layer are broken apart, literally. And so they release their cell contents, which include all kinds of proteins and, what's the name of those flags on our red blood cells and A, B, C blood cells, blood cell types? Antigens, antibodies, all those are released. And some of them have a signal or cause a signal of muscle contraction. So it's like built in. The cells all burst, and then that smooth muscle starts to contract when they realize there's dead parts of their bodies laying around everywhere, sort of. It floods that local zone. Well, some of those proteins or those chemical messengers also start working on platelets. What's another name for platelet? Somebody help me out here, make me proud. Still no guesses? Thrombocytes. A thrombus is just a clot or a collection of thrombocytes. I told you, nobody ever remembers this. Every class, for some reason, this one word, they cannot remember it. Platelets are thrombocytes. I'll show you a picture to demonstrate all this here in a minute. Actually, I'll go ahead and pull it up now. I know exactly where it's at. So you can look at it while we're talking. Okay, those red things are red blood cells. That white stuff is fibrin we're getting ready to talk about. This picture has the platelets highlighted with pink. They're not true cells, they don't have a nucleus, but they are involved in this clot. This is a clot. You can see all those red, this is basically a microscopic view of a scab, sort of. Okay, so those thrombocytes are in there, and when they start getting excited in this platelet phase, still primary hemostasis, they go into an adhesion mode. I'm putting mode up there as my own words. What does adhesion mean?
Sticking to something.
Yeah, they just get sticky. And then the more of them that are activated in that way start releasing other chemicals. And so other neighboring platelets release signals, then everybody starts to do this. What does that word mean?
How do you pronounce that?
Aggregate.
Aggregate? It's like spill, like, it's like getting like inflamed.
No? Think about, I got a bunch of different rocks, sized rocks, and I put them through a screen, and I keep shaking it, and the small ones end up on bottom, and the top are on top. That's aggregating things. It's like collecting and sorting out. That's probably a poor analogy for this, but they just start grouping together. And piling up. You can put pile up down there. Technically, though, they're all saying, okay, I'll take this job, you take that job, we'll take these jobs based on the chemicals they're receiving first. But they're aggregating, they're going into different modes and stuff. This is just the neatest thing. And that's it. That's primary hemostasis done. Okay? So this all happens in a matter of seconds, right? Now we can tell the blood or have the blood to start actually becoming thick in terms of making a seam over this area. So coagulation phase involves, I'm reading at the bottom of 111, left side, coagulation phase involves a complex and highly regulated cascade of enzymes and other factors whose activation ultimately result in the formation of a blood clot. A mesh of fibrin, platelets, and other blood cells that closes off the wound. The coagulation cascade begins 30 seconds to several minutes after injury. Yours might last a little longer or shorter based on your blood condition, right? Okay. Does everybody understand what they mean by cascade of enzymes?
Is that like a decline? Moving?
It is moving.
Okay.
So if I have these, I'm not trying to make this sound like a scientific experiment, but if I have part A and part B floating around in my blood, and they are components of part C, which is the thing I actually need right now at this moment to do, the protein I need to do it. Sometimes they will come together, and this can actually be the part of a even larger protein complex. And so one has to happen before the other one can happen. They start to cascade because they all keep showing up.
Okay.
And they're just enzymes being put together like the lock and key that you've heard about in science class in 8th grade and becoming active. Then there's other enzymes that will come and break them apart. So let's just go look here on page, I keep wanting to go the wrong direction for some reason. 112. Uncommon pathway down there between prothrombin and thrombin. That reaction can't that signifies a reaction. It's prothrombin with this arrow becoming thrombin. Okay? There has to be another enzyme involved, which is factor X up here. And then once that's done, thrombin can go on and work on turning fibrinogen into fibrin monomer. Okay? I'm just trying to define what the word cascade and what some of these enzymes look like actually. So let me finish, let me go ahead and tell you. What's some of these words you see in this thing in page 12, this diagram that we've actually tested before, or as an additive? You would find this in chapter 8 that we've looked through quite a few times.
You're asking what we've tested
Yeah,
for?
we know about additives and like parts of blood tests that we're looking at. You remember me describing an APT and a PT, prothrombin time, activated partial prothrombin time. Okay, so now we're looking at the actual things within this cascade that we're going to test to determine if someone's clotting correctly. Some of it comes from here. That's what we're looking at within that cascade when we get a PTT test. Pretty cool. Yeah. Okay. Obviously, it's different if they're taken, like an anticoagulant in the hospital or by medicine, by mouth and stuff. So, all right, you got it. So the coagulation phase, continue back here.
I have a question.
Yes, ma'am.
Like if your blood's thin, like looking at that picture, and like you have problems with your platelets, what would that look like then?
I don't know. That's normal. Blood clot due to an injury. I don't know. I'd have to do a little searching, but I'm curious to know too. There'd probably be less in there. The fibrin could be thinner and not have as much tensile strength. Could just not be there, period. Whatever gene is messed up. But really, most disorders I know of are the formation, the ingredients for that clot are the problem in hemophilia and stuff like that. They're missing things to activate this very common biological process that's seen throughout all life pretty much with blood in the veins. Coagulation. So, that's a good question. It involves a complex and highly regulated enzymes that cascade and other factors whose activation ultimately results in the formation of a blood clot, a meshwork of fibrin, platelets, and other blood cells that closes off the wound. So coagulation is initiated through two different pathways that feed into a single common pathway, and they're just talking about two pathways in this common pathway, all right? So either one of these reactions at the top here can start Stewart factor X and prothrombin into thrombin. It's all, not that it doesn't really even matter. The extrinsic pathway begins with the release of tissue factor by endothelial cells, which combines, and that's what I was just talking about, endothelial cells be tore apart, those factors. Combines with calcium ions and coagulation factor 567 from the plasma to form active enzyme. The intrinsic pathway is initiated when other plasma coagulation factors contact materials exposed to blood vessels is damaged. Yada, yada, yada. Enzymes from both pathways then enter the common pathway reacting with factors X, yada, yada, yada. Here's where it is important. Prothrombin. Inactive prothrombin is converted to active thrombin, okay? So what you need to remember about this right here, this coagulation phase of hemostasis is that, one, prothrombin turned into thrombin. And I want you to remember that it's inactive. I think usually I would gloss over that, but we've been talking about it enough now. I think you guys are getting what I'm saying. I'm probably repeating a lot of things you already clearly understand. Okay, and then once that happens, thrombin is then able to activate and turn into, just make sure I'm not telling you, fibrin. And actually it's fibrinogen. Why doesn't the text say that? Oh, it has to combine with fibrinogen. Okay, my bad. And then finally, we get to fibrin. That's the strings you see on the clot. Pretty neat, huh? I hope I didn't goof that up and confuse people. For right now, let's just remember that under this phase, prothrombin is converted to thrombin, which also helps fibrinogen convert into fibrin. The way to remember that is pro, meaning it's like a progenitor, it comes before, and then gen is going to generate, or it's the genesis of fibrin, it's the creation of fibrin. If that helps you. Okay, so now we got fibrin. We got platelets. We got some damaged cell vessel wall. And the vessel wall is contracting. Once activated, thrombin converts circulating fibrinogen to fibrin. Fibrin is a fibrous protein whose strands adhere to platelets, they stick to platelets, and endothelial cells at the wound, forming a dense fibrous network that in turn traps other cells. Platelets then contract and pull the edges of the wound close together, allowing endothelial cells to grow across and repair the damaged lining. So Let me go back to a previous picture. Once all those things start folding and contracting, all that will draw up, just like Spider-Man pulling that ship together in Spider-Man Homecoming. The first Spider-Man of the new Marvel Universe. Any questions? I think this is just one of the most fantastic things that we can study about. Okay, well, we got to do something with all that when it's over. I'll give you a break in just a minute. I'm almost done. Fibrinolysis is the final phase. Let me just take my book with me. I'm reading at the bottom of page 111 on the right. Fibrinolysis. It says, as wound is closed and tissue repair commences, fibrin itself is broken down slowly in a process called fibrinolysis. Remember, this lysis means to cut. Okay? It's like glycolysis is the cutting apart of a glucose cell. We had a long discussion about that. I remember it. Okay, this creates something called fibrin degradation proteins, or products, I'm sorry. They are monitored to diagnose sometimes something called DIC, an abnormal blood clotting condition that happens in pregnant ladies. I forget what we call it. It's like when their blood pressure's out of whack, is it a crisis? Eclampsia. I'm still not sure about eclampsia, what happens during it, but that sounds like it's one of the associated factors to me. Anyways, I don't want you to remember DIC. I'm not going to test you on abnormal blooding disorder, stuff like that paragraph. You should know fibrinolysis needs to start, and these fibrin degradation proteins can sometimes be monitored. And then fibrinolysis is controlled by plasmin, an enzyme made from plasminogen. So let's go look at our thing here. I don't see plasma on here or plasminogen or nothing. Okay, so they're not going to be on the thing. That it's for clotting, not breaking down of a clot. Plasmin plasminogen is created into plasmin. There we go. And because plasmin is important, all right, that's what we're trying to get to. By something, this thing right here, it's called TPA, tissue plasminogen activator. Okay, and this is the clot buster drug you hear about when people need to go to the ER and they need the clot buster. Like licensed nurse practitioners, they recently got the authorization to give it like in the last few years because it's such a great drug and so vital. You can only give it if symptoms have been onset for like 6 hours or less, or 4 maybe. And it can totally reverse the effects of a stroke. So we just bottled that and are like using it now, okay? Do you feel like you understand what you need to go back and learn and be able to talk about for each of these 4 phases? Like you have the information, you know where to find it. I don't expect you to know it right now, but I'm gonna go over it one more time, okay? You get injured. The vascular wall is actually damaged. It starts to spasm and contract to stem bleeding. Platelets are activated. Some of them start to get sticky. Even more start to get sticky and sticky and sticky until they're all grouping together and clumped over this one spot. Prothrombin then is activated into thrombin, which helps fibrinogen activate into fibrin, and now we start seeing these little strings precipitate all over that big pile of platelets laying there.
prothrombin, I can't pronounce it, it's inactive right there. When it moves to thrombin, it activates, right? Is that what you're saying?
Something turns prothrombin into thrombin,
Okay.
which is an ingredient for making fibrin. Did that answer your question?
Yeah.
Okay. I named, right here, I named one of these arrows over here and called it TPA. I didn't do that in any other of these things. I'm just saying prothrombin is activated by an activator into thrombin, and then actually it's an activator for what we're looking to get here. So I didn't want to get that TPA stuff, don't let it confuse you. Where's the video at? It's 1 minute.
What is a physical change and what is a chemical change? We add water to 2 ionic compounds to see what happens: lead nitrate and potassium iodide. Both of them dissolve in the water, but this is only a physical change. The bonds in the compounds are broken and they are now ions. Lead iodide.
Oh man, what is wrong with
Water
me?
and melting it.
Anyways, you ever seen a chemistry reaction when there's 2 clear liquids, they could pour one into the other and like crystals start to form immediately? It's precipitating. That's sort of what's happening when these things come together for fibrin. Like that's what I imagine in my head is they start to just precipitate. And tiny crystals that are subatomic are building on others, making lattices. Okay. All right then. Then it will come be broken down and recycled. How long do red blood cells live for?
That I can tell you.
120 days
Okay, so that's the cycle, the 3-month cycle.
for red blood cells. That's like the first thing I ever taught you on here. Go take a break.